Chapter 6, Common Core Practice. All right. We're talking about functions. Identify the mapping diagram that represents the relation and determine whether the relation is a function for that guy right there. Well, first off, let's make sure that we identify the correct thing. We have negative 3, we have negative 1, we have 5, and we have 8. So negative 3, negative 1, 5, and 8, that's part of the domain which is the left bubble, so not you and not you. Now I have to figure out if these guys are a function or not a function. Well, if it's a function, that means the x's don't repeat. So my x's are negative 3, negative 1, 5, and 8. Looks like those x's don't repeat, so it looks like we have a b here. This is a function. Is that it for page 1? Ooh, page 1 done. Page numero dos. Looks like I have the same type of problem as I do for page numero 1. I have negative 8 on the left, negative 5, negative 8 again, and 7. So I have negative 8, negative 5, negative 8. I'm not going to repeat negative 8 again. And then 7. So that's not going to be u, and that's not going to be u. It goes to negative 6, it goes to 2, it goes to 1, and it goes to 3. So I have two pictures on the bottom. Negative 8 is used twice, which means it's not a function because the x's can't repeat. So that's that for that. Use the vertical line test to determine which graph represents a function. Well, the vertical line test says that if a vertical line were to pass through a graph, this is a vertical line, and hit the graph not once but twice or more, it is not a function. So that first guy is not a function. Let me just draw a vertical line there. We're good. Vertical line. We're good. We're good. We're good. Ooh, looks like that is a function. But let's just make sure. That is a vertical line, so it's going to hit like 1,000 billion trillion infinity times. And vertical line hits here twice or here twice. Pick a spot. The answer is C. Problem 3. Done do. Problem 4. Use the graph or table to write a linear function that relates y to x. Normally, if we had a calculator, we would do a little something called linreg, but I'm going to do that differently here. In previous videos, I've done linreg, but I have all the time in the world, and I'm not going to do linreg. I am going to give myself a little bit more space, and I'm going to do the old-fashioned method of doing these types of problems. The old-fashioned method says that I figure out the change in my x values. So it looks like from negative 3 to 0, I go up 3. And from 0 to 3, I go up 3 again. And from 3 to 6, I go up 3 again. And from 5 to 6, I go up 1. From 6 to 7, I go up 1. From 7 to 8, I go up 1. So what that means is my slope, or my rate of change, is the change in the y's over the change in the x's. Okay, my change in the y's over here was plus 1, plus 1, plus 1. So my change in y's is positive 1. My change in x values is plus 3, plus 3, plus 3. So over 3. So if I were to turn this into slope-intercept form, what I have so far is y equals 1/3 x plus b. So that eliminates these guys. Well, what's my b? Well, fun fact, b stands for the y-intercept. And the y-intercept always exists whenever x is 0. If only I knew what I would have if x was 0. Wait a minute, I do. When x is 0, then the y value is 6. So my b is actually 6. Y equals 1/3 x plus 6. My answer is B. Now, of course, it's not always convenient. Maybe I don't always get a 0 for x, and we'll probably run into that, and I'll show you what to do when we run into that, but ain't my problem now. Problem 5. My job is to find the equation, I assume, of this guy. All right, well, let's write it out as y equals y equals mx plus b and figure out what we know. M is the slope. So what's the slope? Rise none over 1. rise none over 1. So 0 over 1 means, oh, it's a horizontal line, which means the slope is 0. Oh, that's simple. Y equals 0x. What's my y-intercept? Well, it looks like it's going through -3, so -3. Well, that's not an option. Well, that's because 0x is no x's. Y equals nothing minus 3 is just going to be y equals -3. B. List the ordered pairs shown in the mapping diagram. Well, my x values are going to be 3, 5, 7, and 9. My x values are going to be 3, 5, 7, and 9. Nope. 3, 5, 7, 9. Yep. 3, 5. Nope. 3, 5, 7, and up. Well, that makes life easy, doesn't it? I have to get used to scrolling. The output is always going to be the y. Is always going to be equals. 6 is 6. Times is times. The input is x. Y equals 6x. Y equals 6x. Easy page. Okay, write an equation that describes the function. One of these again. Well, we need to write out y equals mx plus b. The slope, m, is the change in y's over the change in x's. The change in y's over the change in x's. So it looks like the x's go up 1, up 4, up 4, up 4, up 1, up 1, up 1. So the change in y's, m is the change in y's, which appear to be 1, 1, 1, over the change in x's, which appear to be 4, 4, 4. Okay? So that would make what I have so far, y equals 1/4 x plus, I don't know. Well, if it's 1 over 4x, it's definitely not u, and it's definitely not u, but b and c are completely different. So 1 over 4x, I know, taking 1/4 of x is the same thing as taking x and dividing it by 4. The answer is C. I don't even have to do the rest. God is good. And maybe soon we'll go over what to do if we have to do the rest, but still not there yet. And we're taking what we are given. It would be nice if I could talk. Describe the relationship between the two quantities. Well, I have an object, I have time, and I have dollars. I'm not even looking at my option. It looks like as I have an object, it increases in value and then like increases faster and faster and faster and faster and faster. So if like I have a baseball card, it might be worth $1 this year, and it might be worth $3 next year, and it might be worth $10, then it might be worth $100, and it might be worth $1,000. Things are growing super, super, super fast. So is the value of the antique increasing rapidly at a constant rate? No, because constant would be like it goes up and over, up and over, up and over. Constant's a straight line, so it's not A. Okay, B says it's decreasing, and that's wacky. I mean, the value of the antique starts off increasing slowly, but increases more rapidly as time passes. That's true. And the value of an antique increases quickly at first, but then increases more slowly as time passes. Well, that's not true at all. All right. Describe the relationship between the two quantities. All right. So we're talking about stamps. Big stamp collectors in the house? No? No one? Okay. So it looks like, I don't know, if as time goes on, your stamp is $1. And then all of a sudden it's $2. And then all of a sudden it's $3. It's not going to be like $1 and then $1.01 and then $1.02 and then $1.03. It jumps its cost. So the cost of stamps increases instantly as the amount of stamps purchased increases. Is that what we're doing? Stamps purchased? I don't think we're talking about stamps purchased. So I'm going to put a big question mark at A because I don't know where they're getting purchases come from. Or where that comes from. The cost of stamps decreases. Well, that's nonsense. That's nonsense. The cost of stamps increase at a constant rate. That's not true. From the last problem we did, we didn't see this going on. And the cost of stamps is constant at first and then increases steadily as time passes. Well, that's not true either. So it has to be A, but I'm not happy with the problem because it increases instantly. That's the only one that seems to make sense. All right, use the vertical line test to determine whether the relation is a function. Well, the relation is a function if it passes the vertical line test. I have 1, 2, 3, 4 points to worry about. So hits it only once, hits it only once, hits it only once, hits it only once. Is this a function? Yes. And that's what we're doing. Oh boy. That's what we're doing. We're just determining whether or not it's a function. So we can say it is. It is a function. Drawing with this thing isn't the best. Model the function rule y equals 3x plus 0 with a table of functions or values and graphs. Model. Sounds like me back in high school. So what I do is I take these numbers right here and I plug them into that equation up there. 3 times negative 1 plus 0 is going to be, I'm going to make this bigger so I can write it better. 3 times negative 1 plus 0 is negative 3. 3 times 0 plus 0 is 0. And 3 times 1 plus 0 is 3. So now when I want to graph this, I have 3 points. I have negative 1, negative 3, which appears to live right around there. I have 0, 0, which will live right around there. And I have 1, 3, which will live right around there. And if I had a normal ruler or if I had anything like that, I would draw a much straighter line than that. But that's what we're doing. We're using a table and a graph to represent y equals 3x plus 0. Cool. What else? Is the function blah, 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 or is the relation a function? Well, its relation is a function if the x's don't repeat. So negative 2, negative 1, negative 1. Oh, look, the x's repeat. Is it a function? No. Why? Negative 1 repeats, and negative 1 is an x value. I hate writing with this thing so much. List the ordered pairs shown in the mapping diagram, then determine whether the relation is a function. Well, the relation is a function because negative or regular 2 goes to 3, 6 goes to 4, 8 goes to 11, 10 goes to 4, 10, 4, old buddy. Determine whether the relation is a function. It is a function because none of the x values repeat. All right, on to the hardest problems on the whole packet. Linear or not linear? Well, linear is either a straight line or in the form y equals mx plus b. So, are you a straight line? No. So you're nonlinear. Are you in the form y equals mx plus b? Well, not really, but if I subtracted, let me just write out that guy right there. Let me just write it out. Y plus 7 equals 2x plus 3y. If I subtracted 3y from both sides, right, crossed you out. If I also subtracted 7 from both sides, crossed you out, you would be negative 2y equals 2x minus 7. If I divide everything by negative 2, and let me write it up here right above my head, you would have y equals negative 1x plus 7 over 2, which is linear. Now, if you're like, oh, did we have to go through all that? Couldn't I just look at the fact that there's no exponents or square roots attached to x? Couldn't I just do it that way? Yes, you can. But, I'm an overachiever, so why not? You're not a straight line, so you're not linear. I said you're non-linear. This is not my day. All right. That was great. It was fun. Problem 18, though. The table shows the value V in thousands of dollars of a house after T years. Does the table represent linear or nonlinear functions? Explain. Things that are linear follow a pattern. okay? And as we did before, we would do like y's over x's. We're just looking for the same pattern throughout. For example, t goes up by 1, by 1, by 1. This goes up by 5, by 6, by 4. Right here, down here, the pattern broke because instead of going plus 5, plus 5, plus 5, it went plus 5, plus 6, plus 4, which means it's not linear. If you were to graph those things, you would not get a straight line because the pattern down here broke. So let's take a look at 19, which is the same type of problem, just less exciting as 18 was. If I were to look at the pattern down here, I have, again, plus 1, plus 1, plus 1. And the pattern I have down here, if I do have a pattern, is minus 2, minus 2, minus 2. So is this linear or nonlinear? This is linear because it follows a pattern. Now, I didn't explain, but problem 18 is nonlinear because it doesn't follow a pattern. And problem 19 is linear because it does follow a pattern. The table shows the values y in dollars of car A and car B after X years of ownership. Which function represents a linear function? The function for car A, for car B, both, or neither. So we're going to do what we did in the last two problems, where we have to find a linear relationship by detecting if there's a pattern. So this is going to look kind of funky. For the years here, I'm adding 1 every time. Plus 1, plus 1, plus 1. So there's an obvious pattern right there. For car A, I am going down 4,000, so I'll put 4K, minus 4K, minus 4K. So it looks like car A is linear. Okay. Car A. Okay. What are you doing? You're subtracting 12K. You're subtracting 6K. And I'm going to stop right there. It's cutting in half every time. Cutting in half every time is not subtracting by the same number every time. So car B, that's supposed to be a C. Let me see if I can turn that into a C. Car B is nonlinear. So the question is asking, which function represents the linear function? The function for car A, B, both, or neither? Just A. Just car A. 21. Describe the correct error, or describe and correct the error in drawing a mapping diagram of the set of ordered pairs. So 3, 5, 7. Oh, it's backwards. Is that all it is? Just backwards? Backwards. Well, describe the error. Is it backwards? So let's actually put it in the correct order. So my input is supposed to be 3, 5, 7, 9, 12 in that order. 3, 5, 7, 9, 12. My output is supposed to be 5, 3, 8, 7, 8, but not in that order. So let me put it in order. 3, 5, 7, 8. Okay. 3 goes to 5. 5 goes to 3. 7 goes to 8. 9 goes to 7. And 12 goes to 8. Okay? Function. It is a function, but that wasn't asked. Does the graph represent a linear function? No. Why? Because it's not a straight line. And you might say, sir, you're wrong. It's actually 2 straight lines. I know that, but it's not a straight line. So therefore, thus, and therefore, it's not linear. So you wrong. All right, 23, last page. Is this linear? I'm not going to describe why because it's the same description as the last one, but it's non-linear because it's not a straight line. So what do you want me to do? Explain it 1,000 times? I ain't. Last problem. Make a mapping diagram for the relation. So we have our domain. You can call it an input. You can call it the X values. I like to call it domain. We have our range. You can call it the output. You can call it the Y values. I like to call it the range. Home on that. My domain are my X values, -1, 0, 3, 4, least to greatest. So it's already in order. -1, 0, 3, 4. My range is -3, 1, -1, -6. So putting that in order would be -6, -3, -1, 1. And I'm going to draw arrows. -1 goes to -3. 0 goes to 1. 3 goes to -1. 4 goes to -6. And that, boys and girls, is a mapping diagram. Is it a function? Yes. So that's chapter 6, Common Core. Bye.